Okay, this is Finite Math Section 3.2. We spent some time in Section 3.1 working with inequalities and graphing them, and now we're going to take that and apply those to what you would call word problems. And, basically I got written down here, in this section we take word problems and put them into a form that we can work with, and I try to break this down into several steps. If you follow the steps, you will keep organized and it will help you get your answer. I think it's very important that you stay organized with this. So once you're given the problem, you need to be able to define your variables. You're going to draw a table and fill in the data. That helps you organize the data. You're going to find the inequalities and what they call a profit function, and there's going to be some where it'll be a cost function. More on that later on. Today we're just talking about profit. And then you're going to graph the inequalities. Now, I'm going to show you one example, and that's really all we're going to do today. But then when you move on, when we get to section 3.3, then we're going to go ahead and I'll show you how to finish the problem. And to do that, you got to be able to find your vertices. Then you plug each of those vertices into your profit function or cost function, depending on whether you're minimizing or maximizing. And then from there, you'll decide what your answer actually is. So these are the steps, and if you follow those, you're going to find yourself in pretty good shape. When, if you're working a problem like on a test and you turn your work in, make sure I can see your steps. That'll help you out. These problems are actually pretty long. Now, I know on the test they'll break it up into different parts. It makes it a little bit easier for you, but try to make sure you're organized. That helps me follow your work. Okay, so here's the problem that they got in the book. I'm just going to read through it. It says a furniture manufacturer makes two types of furniture, chairs and sofas. For simplicity, we're going to divide the production process into three distinct operations: carpentry, finishing, and upholstery. I'm going to pause here a second. As we go through this, I want you to imagine that you are actually running the business and you're producing these chairs and sofas. And to produce them, there's different things that you've got to have. In this case here, they're saying, okay, there's got to be some carpentry, which means, the wood part of it you're going to put together. And then there's some finishing that has to go through with it, fine tuning, whatever you want to call that. And then once you have all that done, then you got to put the upholstery over the top. So those would be your three parts. The amount of labor required for each operation varies. For manufacturing, a chair requires 6 hours of carpentry, 1 hour of finishing, and 2 hours of upholstery. Manufacture of a sofa requires 3 hours of carpentry, 1 hour of finishing, and 6 hours of upholstery. Due to limited availability of skilled labor, as well as tools and equipment, the factory has available each day 96 labor hours. Sometimes they call it labor hours. You can just say hours if you want to. 96 hours available for carpentry, 18 labor hours for finishing, 72 labor hours of upholstery. And the profit for each chair is $80, and the profit for each sofa is $70. And then here's the question. They want you to figure this out. How many chairs and how many sofas should be produced each day to maximize their profit? So as we get into these inequalities, you're going to have two different main types of problems. Okay, maximizing the profit. Whenever you have a business, you want to make as much money as you can. Or on the other side of it, you minimize the cost. So as you're producing things, you want to keep your costs to a minimum. So we minimize the costs. Okay. Now, I'm not doing a minimized problem today. All I'm doing is doing a maximization. Man, I'm only doing one of them. Okay, so first of all, look at that paragraph, and you got a lot of numbers involved there. And it's very hard to keep track of what all of them are. So, okay, let's define a variable. So, two different variables. We're just going to use x and y, and x is simply going to be the number of chairs, and y is going to be the number of sofas. Okay, now we're going to organize that data. I've already got it in here, but let's just take a look. All those numbers that I had up here. So as you go back up here to the top, let's see, the manufacturing of a chair requires 6 hours of carpentry, 1 finishing, and 2 upholstery. 6, 1, and 2. 6, 1, and 2. That's the number of hours for a chair. I'm going to skip down to the bottom. Right here, the profit for each chair is $80. So there's your first column of numbers. Go back up here. The manufacturer of a sofa requires 3 hours of carpentry, 1 finishing, and 6 for upholstery. So that's 3, 1, and 6. I'm going to just circle these collectively, 3, 1, and 6. And then right here, your profit's 70. So by putting it into a table like that or a chart, it helps organize where your numbers are. Okay, and then these other numbers are probably hard to understand at times, but the factory has limitation. Okay, so 96 right there, there's 96 hours available for carpentry. You know, I guess the easiest thing is, let's say, you know, carpentry means you got a carpenter. Maybe he's only allowed to work 96 hours each day. Or maybe there's a couple of them, but the total is there's only 96 available. So that goes there. You've got 18 for finishing, so that's where this one comes from. And then you got 72 for upholstery. These numbers over here could be thought of as limits. These are all that's available. So if I had 96 hours available for carpentry, okay, that means I can't go over 96. I could go less than that, but I can't go more than that. Okay, now what? Well, now that you got your chart, now you want to come up with the inequalities. If you go back to the first page and look at our things here, okay, we defined our variables. We just finished the table. Now we're going to do the inequalities, and then we're going to graph it. Okay, once you have the table, getting the inequalities is real easy. You're going to have an inequality for carpentry. Remember, we're going to produce X chairs and Y sofas. So the number of hours that I have available for chairs, if I produce 6 of them, that'd be 6 times X. So I'm going to have 6X plus carpentry's going to use Y hours, or 3 hours of Y sofa. So that's going to be 3Y. And that has to be less than or equal to 96. 6X plus 3Y equals 96. So this whole first line gives you an inequality. Now go to the second line. I've got X plus Y. 1X plus 1Y, or just X plus Y. And that's got to be less than or equal to 18. And then the third line, I'm going to have 2X plus 6Y. And that's got to be less than or equal to 72. So there's your three main inequalities. There are two others, and they don't really show up in any of this data, but you have to have them for this method to work. X has to be greater than or equal to 0, meaning you're not going to produce a negative number of chairs. That would not make sense. And the same thing for your sofa. So you're always going to have these. Okay, now put this in your brain cell someplace. If I ever ask for what the inequalities are, make sure you put all 5 of them. These are obvious. You can say, okay, I got those. They take a little bit of work. These take no work at all and people forget them. Make sure you put those in. Okay, so those collectively are all your inequalities. Now your profit function is just as easy. If you go up here, see where it says profit? For each chair, I'm going to make $80. So if I produced X chairs, that means it's going to be 80X. This is going to be plus 70Y. And I'm going to put P equals. So your profit, that your profit function is 80X plus 70Y. Okay, pretty easy. Okay, now the next step is, if you go back to page 1, the next step was to graph. So I've got this all set up. I'm ready to graph. I already got my inequalities typed here, so I didn't have to rewrite them. Now, if I'm going to graph this, then what I'm going to do is I'm going to find my intercepts. So when I look at the first one right here, my x-intercept, remember you cross out the y's, so 96 divided by 6, x is 16. Y is going to be 32. That's for the first inequality. You know, and sometimes I'll label these L1, L2, and L3 because they're all going to be a different line. I'll come back to that in a second. Okay, my intercepts for the second one then, x is going to be 18. Y is going to be 18. And on the third one, x is going to be 36. And y will be 12. Okay, so when you get your grid like this basically goes, there's 10 squares each way. You're going to do your own thing because you'll have graph paper. You'll do what you want to. And by the way, I definitely would do this on graph paper and spread it out so it's easy for you to see. Otherwise, you get confused real easy. You'll notice on the graph that I have down there already, I've already put my intercepts. So my x-intercepts, I've got 16. So 16's that dot. Here's the 18 and the 36. So I got that. For my y-intercepts, I got 12, 18, and 32. And what I did, each square represents 4. So if I went all the way out here, you don't have to put this, but just to show you, it goes 40 each way. So each square is 4. And I don't like a lot of numbers. I want just enough numbers I can tell what your increments are. Okay, so let's go back up to the first line here. My x-intercept is 16, so that's here. My y-intercept's 32, so that's up here. So my first line goes like this. And remember up here how I labeled that L1? Now I come down here and say that's L1. And the only reason I do that is later on, these problems are so long, if you make one little mistake, then you're going back, and this will help you keep track of what you did. You're going to do it today. You may come back 2 days later and say, what did I do? By labeling that, that helps you go back and figure out what you were doing. Also, these are inequalities, so you're going to have to either shade above or below. These are all going to be below. If you put 0, 0 in, you'll find out that's going to be on that side. Now, you remember I did hash marks. You're going to be doing 3 graphs on the same one. So now what I do, I call these tick marks. I make them smaller. But you can basically see it's going to be everything coming down. Okay, the second line hits at 18 and 18. So let's draw that line in. And that is line 2, so I'll label that L2. And my tick marks are going to go down. 0, 0 works. So you don't want to have a whole bunch of stuff there because it gets real confusing. And then my third line hits at X is 36 and Y is 12. So let's go ahead and get that one in. Of course, that's L3. And the tick marks are this direction. Okay, now also don't forget this up here. X greater than or equal to 0, that means that's all the points on this side. You'll notice when I drew this, I only put the first quadrant in for that reason. When X is greater than or equal to 0 and Y is greater than or equal to 0, that means you're talking about the first quadrant. So that makes that simple. So in a sense, you've got 5 lines there, and I've shaded one of the sides for each line. Now, where do they all intersect? Well, if you'll notice, everything in this section here. So there to here. And then you got this one coming down here. And then you got this. Coming here, and this one coming up here. Now, when you're doing yours, I assume you're probably doing everything in pencil. So my suggestion would be to darken those edges. Okay? And then some books actually call this a polygonal region. And that polygonal region, we talked about this earlier, but that's your feasible set. Sometimes called a feasibility set. And if I wanted to finish this off right, then I'm going to shade in everything inside that polygon. Okay, so you drew all your lines and you found out where they all intersect, and you find out it's that polygonal region. Now, essentially, that's all this section does. It talks about, going through those steps. You decide your variables. You create a chart so you can come up with the inequalities and your profit function. Then you graph everything, and that's going to give you your feasibility set. Now, I'm going to jump ahead a little bit, and I'll do more of this in the next section, but this polygon has 5 edges. I've got an edge going up and down here. I've got one here, 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 and here. Those are all the ones I darkened in. Those are edges. I'll write that down. So I got 5 edges, and I'm going to have 5 vertices. This is one of the vertices right here, and you know that one. That's one's going to be 0, 0. And you're going to have a vertex over here. That one, since we hit at 16, that's 16, comma 0. There's another one up here. This is going to be 0, comma 12. There's going to be another vertex right here and another one right here, but I don't know what those are yet. And then what we'll do in the next section is I'm going to work on showing you how to find what the coordinates are. Ideally, you should be able to look at your graph and come up with the answer. Like right here, let's see if this hits at 16. So I got 4, 8. This should be real close to 8, maybe 9, comma, maybe 9, comma 9. But I don't know for sure. Next section, I'll show you how you figure that out, where you know exactly what they are. You have to know what they are. And then once you find what those points are, then I'm going to show you how to come up with the actual answer to the problem, which when you go back to the previous page, it said right here, how many chairs and how many sofas should be produced each day to maximize the profit? Okay, to answer that, we got to go to section 3, and that's what I'll do next time. Okay, so real important, make sure you know your steps. And like I said, I only did through here. The next lesson, we'll do that. Here I showed you an example. Got your variables, did your chart, got your inequalities, did your profit function. Then we graphed it. And the next thing is find out what the vertices are, and then you can answer the problem. Okay, I'm going to quit there for today. And you should be good for the rest of the week now. And all right, see you next time.